Let us start another concept which is known as bow tie. Actually, bow tie is not a new thing. It is basically combination of fault tree and event tree, but it gives the holistic picture from the basic event failure to the accident scenarios at the end state. So, that is why in past couple of years this has been very popular, and I want to explain this bow tie concept primarily with examples, because the basic principles underlying the bow tie is already discussed, that fault tree and event tree. Nevertheless, let us know that this concept and utility of bow tie. So, introduction, terminologies, bow tie tool and management, and several examples. So, that is what we will be discussing. And although I have written here that the book written by Komamoto and Henley, that Henley, Komamoto and Henley. So, but there is another book which we have taken into consideration, that is by Madares. So, that is also reliability and risk assessment. So, later on I will show you the reference for Madares also. So, we primarily rely on these two books and the concept of bow tie, and this is what is the discussion for the next 30 minutes of time, and you will enjoy it because most of the things already you know. So, to some extent it will be revisit to fault tree and event tree, and in another way it is basically the holistic view of for prevention through design also. So, if we go back to the history, then it was developed to address the safety case in the oil and gas industry, that is a Piper Alpha incident. And after Piper Alpha incident, so far what I know that this bow tie concept become popular, and in fact what I understand from the literature that in first couple of years it is increasingly popular. So, what it does basically, as I told you, that it basically links the basic event failure to the top event in the fault tree, and then linking to event tree, and finally a huge path from basic event to the accident scenarios. So, if the accident scenarios is the consequences and the basic event side that component level hazards, so then what we basically say that linking from the hazards and to consequences, that means the causes of hazard occurrences, and ultimately then up to consequences. So, its relationship, the total relationship, and another very important one is that it will talk about the preventive and mitigative measures requires for along different accident paths. So, it will also give you the total accident path, but it is a very exhaustive one. So, it is not possible to develop maybe for the entire system. So, maybe for the safety critical system or safety critical subsystem you can go for this. Further understanding can be improved by examining the means by which the preventive and mitigative measures fails. So, what I mean to say, you have preventive mitigative measures, but it can fail. How it will fail? So, that means an identifying risk control system which helps to maintain the integrity of the system. By integrity we means mechanical integrity, operational integrity. Okay. So, so this is what is basically the use of bow tie. So, terminologies are very much known to you: hazard, and you know, top event, basic event, consequences, preventive measures, mitigative measures. So, what I mean by preventive measures, that means actually when we talk about any accident, So, the top event, then whatever you do to so that the top event will not occur, so that is basically nothing but the cause will not occur. So, similarly mitigative measure is the what you will do that the impact of an accident will be minimized. It is nothing but that you will basically minimize the impact or recovery from the consequences. So, in one way or other way these are the explanations. So, many a times I have explained all those things. So, I do not think that you require further explanation here. So, as I told you that particularly this BOWTIE tool. So, that means it is from the hazard, then causes, then preventive measures, top event, mitigating measure, consequence. So, that is the sequence, and you see we are saying the top event with reference to probability. When we are talking about consequence, we are bringing the event tree. So, that means fault tree and event tree will be linked, and there are simple design, axiomatic design, virtuality, many things that can be added to their analytics. So, when all will ultimately leads to either identifying hazards or underlying the safety critical factors or underlying the factors that contributes towards the hazard occurrence, initiating mechanism, all those things. Then what kind of preventive measures, mitigative measures, those things will be required, and ultimately the risk control system and how risk control systems will be made operational, will be monitored and controlled. All those things can be put together under BOWTIE tool and management. So, that aspect BOWTIE tool and management will not be discussed in this particular lecture, but later on if we will try, but I am not sure that we will go up to that BOWTIE tool management part, and definitely you will be able to do it. The reason is because you have enough time after going through this course, you practice this. So, here we are again relying back to the system, that is basically pressure tank system. Here intentionally I have created the top event as pump overrun, because we think that the tank rupture is the basically the accident state. So, it is better you work on pump overrun, because if pump overrun can be minimized or can be eliminated, that overpressure condition can be eliminated, tank rupture will at least because of that deviation or overpressure it will not happen. So, this part you have seen in my last lecture also, that why pump overrun takes place, because the current to motor too long, because why current to motor too long, because the circuit is closed too long, and then contact are closed too long, switch is closed too long. This way we have developed. And then what I am saying, that if pump overrun is my top event, then what happened, the overpressure condition will arise, and in order to arrest the overpressure or fight against the overpressure condition or bringing back the overpressure situation to the normalcy, so there are different protection measures are there. So, like alarm is there, alarm should work, then operator should work. So, anyhow alarm is a signal only. So, I am not using alarm here. That means what I am straightway going that definitely under pump overrun situation the operator should work. You can add alarm, no problem, but for the time being I am saying that operator should shut down the system. If operators fail to shut down, operator shutdown may succeed, may not succeed. If operator succeeds, what will happen? Then pressure protection, that is not applicable here, because not required. So, then that means the relief valve case, it is not required maybe, because it is pump overrun, operator shutdown, so that may not be required. So, then what happened? No rupture situation will be there. This is my planned state. What way other way are in the accident scenarios, But if operator shutdown fails, then what will happen? Overpressure, that condition, this will increase, more gas will be fed, then ultimately the relief valve should work, and then if relief valve succeeds, then there is no rupture again, although there will be minimum loss of that gas, but if relief valve fails, the rupture will take place. So then I can tell you that if I know the MCS here for the pump overrun, the minimal cut state, then every MCS leads to this, and then the path is that pump overrun, this takes place, and this one is this one, OS going to this. What you have done here? You have created a bow tie. Why? One hand this fault tree, another hand event tree. This fault tree talks about why pump overrun, event tree talks about if pump overrun takes place, how your system behave against pump overrun to restore the normalcy. If your that system protection measure fails, then finally the rupture situation, the accident situation will take place. So it's a beautiful way of looking into the problem. You may say I start with this and then ultimately one big fault tree will be there, so that we have seen earlier. Other way you can say no, because tank rupture, if it is the top event, that means everything has happened and your preventive and mitigative measures are not that much differentiated. But here if I know that pump overrun to be arrested, so in order to arrest pump overrun, what I will do, that are mitigation that are basically mitigating the effect of pump overrun. And then what is the accident path here? So accident path will be suppose let us this event 2 occurs, this is row, this is, and then one more event should occur here, suppose event 4 occurs. So 2 and 4 will be the one of the MCS. So MCS, suppose this is 2 MCS 2, this is nothing but 2 and 4. So between 2 and 4, so these two together along with this path will lead to no rupture. 2 and 4 happen here along with this path. So 2 and 4 along with this path, it will be rupture. So 2, 4 occurs here, operator shutdown occurs, operator shutdown fails, means operator fail to shut down, and protection measure relief valve also fail, then rupture condition will take place. So that means 2, 4 OS PP, that 2, 4 combiningly, this is PO pump overrun, OS and PP, they are all independent event. So they are multiplied, and this is what is the accident sequence. And if we know the probability of this PO, probability of OS and probability of PP, I can know the probability of this accident sequence. Okay. So that means this is accident sequence 1, sequence AS2 and AS3, but fortunately these two sequences are same, no rupture condition. So no rupture condition probability will be probability of this plus probability of this, whereas rupture condition probability will be this. Okay. So this is what is our bow tie. So bow tie. What on this side event tree, and this side if I just rotate this one with AND gate, what will happen? You are getting two side here, this and this, then OR gate, here also OR gate, then 1, 2, 3. So 1, 2, 3, again 1, 2, 3. These are all, so this. So ultimately what happened? It looks like a bow tie. It's a tie. Okay, this is the tie. So if I say this is my top event, this bow tie, this top event, and this side is basically why this event occurred, and this side what will happen if that event occur. If this is the, if I say that we want to prevent the pump overrun, then these whatever we do here, what do you do? If you can, one cut state is 2 and 4, primary contact failure, primary switch failure, this should not simultaneously occur. So you put a prevention so that this should not occur. Then this is prevention to this. Similarly, there will be several cut sets. So all cut sets, if not doesn't occur, then this will not occur. Now question is that the preventive measures whatever you will put, that also will fail. So ultimately there is a possibility of probability of happening this. Then your protection system, operator shutdown, other things should occur, so that pump overrun will not take place. Okay. So this is nutshell what is mean by bow tie. Now I'll just repeat the case, the card set case. For this, these are the card set. Earlier we have discussed how to develop card set, so I am not going into that detail of card sets. So you say that there are 6 card sets to any this occurs, this will occur, this occur, this will occur. So what will be your preventive measures here? You do something so that these two simultaneously, these two simultaneously, these two simultaneously, this do not occur. Okay. Okay. Now what happened? You may be interested to know that okay, I want to know the probability of the accident sequence. Then you have the bow tie. So you first find out the probability of this. Then you know that what is the success of this, and this one fails. It should be reverse. Success should be 0.99 and failure should be 0.01. And in this case 0.5 and 0.5 means under overpressure condition, but these are very hypothetical value given, but it is better always. This is very poor design. It also may be 0.99 and the fails will be 0.01. Then what will happen? 0.00368 multiplied by this will give you the probability of this. So you just change this one. I am not sure this whether this value will occur or not. Okay. But actually purpose was just to demonstrate, but the demonstration should be also practically significant, because operator shutdown should succeed maximum of the time. So other way you can say that means I want to give you other way this can be interpreted like this. If you give here more probability that it will fail, that means you have not understand the system, or the system is actually this is meaningless, should not be there. So similarly the protection measure, this should work for the maximum number of situation. So this is gives you the clue. So if you put more probability of failures, more probability of protection, this second fails, this is not a good one. Accordingly you change this one, and as I told you, this is the initiating event from event tree point of view, and these are the pivotal events. Okay. And these are the basic events, these are the secondary events. Secondary events means which are not known so far, the causes are underdeveloped. Okay. So now I will tell you another one. So as I told you that bow tie uses fault tree and event tree. Here I will show you that how fault tree is used inside the event tree, because the protection configuration also may fail, and then how do you find out the failure probability of those. For example, let me explain here. Here what happened, we are saying operator shutdown, and we are writing that operator shutdown fails with 0.01 and succeeds 0.99. Okay, so now how do you get this probability? So that means there may be, or pressure protection, it suppose fails 50% of the time. It should not be, but let it be like this. Then how do you know this is 0.5? So that means you can have a fault tree of this, you can have another fault tree of this, provided those fault tree will be relevant and significant fault tree. Otherwise, if it is a trivial one, don't do. Okay. So that is what I want to discuss here. Here our this particular thing we have taken from Moderate 1993, that what every engineer should know about reliability and risk analysis, New York. So there he has given this particular system. It is basically fire protection system. That means fire already taken place. Now what should you do so that you will protect your system from fire? Okay, so see that there are different components like nozzle 1, nozzle 2, they are injection nozzle, which basically inject the water to the fire. So, that will be activated to that pump must be there, which will basically supply water to then pump 2. There are different valves, and importantly the water tank is there from where the pumps are basically sucking water and then providing to injection nozzle, and injection nozzle will basically suppress the fire. So, it is a one kind of standby system basically. If this does not work, this will work. If both fails, then ultimately the operator will call the fire department, and ultimately there are offsite power source. If power source will not work, then DG system is there, and obviously there is detection alarm actuator which basically helps in doing the work. Now, let us read the operation details, and so that what will happen, you will understand how this system will work. The study, you see the system is designed to extinguish all possible fires in a plant with toxic chemicals. I have taken it from this particular book. So, it is in detail. The two physical independent water extinguishing two physical independent water extinguishing nozzles are designed such that each one is capable of controlling all types of fire in the plant. Means nozzle 1 is capable of extinguishing the fire, nozzle 2 also able to extinguish. Extinguishing nozzle 1 is the primary method of injection. So, whenever in fire situation, nozzle 1 will work primarily. Upon receiving a signal from the detector alarm actuated device, pump 1 start automatically. So, the detection device is there, it will detect that fire occurs, maybe a smoke is the starting point. So, then immediately what will happen, the nozzle 1, the pump 1 will activate and pumping start, and nozzle through nozzle 1 the extinguishing will start. Okay. So, what way pump 1 start? Drawing water from the reservoir tank and injecting it into the fire area in the plant if this pump injection path okay. Now, what will happen if this pump injection path is not actuated? Pump operator can start a second injection path manually. This is the manual one. If the second path is not available, then the operator will call for help from the local fire department. So, there are 3, one is injection 1, it basically gets signal from the alarm detector, start working. If that doesn't work, then injection system 2 is there, which will be operated manually by the operator. Suppose both the things fail, then operator call the local fire department. However, due to delay in the arrival of the local fire department, the magnitude of damage would be higher than it would be if the local fire extinguisher nozzles were available to extinguish the fire. That means, if nozzle 1, nozzle 2 or nozzle 2, they can extinguish the fire, the damage will be less compared to calling the fire department when these two system fails. Under all condition, if the normal offsite power is not available, offsite power normal supplied maybe through the local grid. So, not available due to fire or other reasons, local generator would provide electrical power to the pump. So, there is standby generator set. The power to the detector alarm actuator system is provided through batteries. So, detection system will work whether it is power is there or not, but it is through batteries, which is constantly charged by offsite power. Even if AC power is not available, the DC power provided through the battery is expected to be available at all times. The manual valves on the two sides of the pump 1 and pump 2 are normally opened, only remain closed when they are being repaired. The entire fire system and generator are located outside the reactor compartment, so therefore not affected by internal fire. Okay. So, now I go back to this again. So, see, this is the primary system for fire extinguishing. This one actuates after getting signal from the detector. If this fails, the second one, this one will work. This one will be basically pump will be activated by operator. If both fails, local department will be called, and you see that the pump 1 and pump 2 takes water from water tank. There is always offside power available. In case offside power not available, diesel generator will basically provide or supply power, and the battery to these systems are always basically recharged, and it is available even if the electric power is not available. So, your work is basically, so you want to know that how good your system is to protect the fire or to extinguish the fire from greater damage. Okay. So, it is basically, see, the fire occur mean accident has already occurred. So, that means it is basically we are talking about when an accident takes place, how your system behaves. So, this is basically a event tree issue initially. So, what we will do? We will first prepare the event tree. Okay. So, let us hope that the fire, how it occurs, that fault tree is known, and the very small probability that fire will occur in this system. Now, there are two things, one is on-site fire protection system and off-site fire protection system. You have seen that on-site and off-site fire protection system, because nozzle 1, nozzle 2 on-site, and otherwise local fire department will come. If on-site fire protection system is successful, then off-site is not required. So, outcome or accident scenario will be that minor damage. If on-site one is failure, then off-site fire protection system may be successful, may be failure. If it is successful, major damage will be there. If this also unsuccessful, catastrophic things will happen. So, this is my accident scenarios. Now, here in this example, I want to show you that how the success of this or failure of this also an issue, because this is basically protection measure. There is success and failure. Now, you can use fault tree here, you can use fault tree here, then you can find out success and failures. So, one fault tree you are constructing here for the system, when fire will take place, what is the probability of fire occurring. Then, if fire occurs, whether on-site protection measure works, what is the probability that it will not work? What is the probability that it will work? Similarly, if on-site fails, whether the local fire department will come and extinguish or not, probability of being a failure. So, that means this probability times this probability times this probability will give you the probability of catastrophic in nature. Okay. So, that is also okay. So, now you have the entire bow tie. For fault, this one may be another fault tree is there, and this side also. Now, here for this you have another fault tree, for this fault tree. So, that means fault tree and event tree in combination, you are able to find out all possible routes of failure, their preventive measures, mitigating measures, all those things are very possible. Okay. So, what I will do, I will show you that these two, suppose the on-site protection measures fail. So, that means this one fault tree, that these two will fail. So, this is this one, the on-site protection measure fails. Failure of primary one, failure of second one, primary injection path 2, primary injection path 1. So, path 1 means the nozzle 1, you see that these are the things, this failure, that nozzle failure, valve failure, another inlet valve, outlet valve, tank not available. So, all those things lead to failure of this, and pump failure also lead to failure of this, but pump failure depend on many other things. And similarly, here but this both the pump are identical. So, that means the pump failure, what will happen, you will find out that there will be common cause. Getting me? There will be common cause of failure, because pump failure there will be common cause of failure. So, that is why what happened, it may be a situation when there are certain causes which cause pump 1 to fail as well as pump 2 to fail. that situation will has to be taken care of here. So, here one additional thing you are learning, that all the basic events, it not that it is basically going to do something separate top events or intermediate events. There are certain things which ultimately may be applicable to different intermediate or finally leading to top event. For example, and those things to be looked into matter, but you have to see that those common causes should not be eliminated. Maybe in one side of the fault tree you use it, in other side you have not used it, that should not taken place. So, now see, we have given a common cause failure, the dependent failure of pump 1 and pump 2 in this side also and in this side also. So, there are method how to find out the common cause failure, and you have to do it, but for the sake of simplicity we have not added here this common cause. How this common cause the dependent failures are quantified, we have not given to you here. Okay. So, what I mean to say, this is basically on-site protection system in that fails, this is given like this. So, that means fault tree, again you are using fault tree within the event tree. Now, you can find out the upside one, the also that will fail. So, in a similar manner you find out the fault tree for this, event tree for this. So, that means what I mean to say, what I have shown you here, not only fault tree here, fault tree here, fault tree for this, fault tree for this also, because otherwise how do you know it is working, the pivotal events are working or not. Suppose you say we have on-site protection measure, then you must know when on-site protection measure fails. How do you know it? You will know from this. Now, you have to develop the card set for this, and then you will know what are the events that if occur will lead to top event to occur. Those events should not occur simultaneously. Okay. So, many a times we give this example fall from ladder. So, you see that fall from ladder, why fall from ladder, this fault tree, and that this I have explained earlier also. Then fall from ladder, what will happen depending on the conditions. Here actually not protection configuration, here basically under what condition this event can take place, whether from which height, what is the contact surface and all those things, and then which body area affected, then accordingly the severity or the consequence has been different. It is primarily basically related to injury severity. Okay. So, that means in not necessarily that you will use only for the high more technology oriented situation the bow tie, it is not. This is an example that which basically can be used also in a manual job or semi mechanized kind of job also, this bow tie can be applied. So, that is why this application I have kept. So, now these two when you combine together, this is nothing but bow tie for fall from ladder. So, my ultimate aim of showing so many bow tie, just to tell you that bow tie can be developed for almost every system for to understand the accident scenarios. Understanding accident scenarios means knowing the path from hazards to accident, and when you have safety critical system, it is better to use bow tie in the sense fault tree and event tree together. By saying fault tree and event tree together, it is another simplification of bow tie. It does not mean that bow tie always requires fault tree and event tree. The issue is that bow tie basically links the preventive side and the mitigative side, preventive measures and mitigation measures. So, you may not develop also fault tree and event tree, you may adopt some other techniques to identify the causes of the accident and to identify that how the system behaves when accident takes place, absolutely no harm. So, that sense bow tie is more versatile. So, here the card sets we have developed, and this part you know, and then finally the quantification part, this is again the repetition. So, but the repetition for the benefit of you, not benefit of anybody else. So, thank you very much. So, in nutshell I said that BOWTIE is an important tool for safety engineering, particularly if you are interested in prevention through design, because from the cause to consequence and for the safety critical system, it is a wonderful tool. So, I recommend all of you, you understand fault tree and event tree, take safety critical system, develop the thing and generate all the accident paths, understand cut set from the fault tree point of view, then understand cut set from the accident scenario point of view. I will be discussing the cut set for accident scenario in the next class. So, be careful, attentive in the next class. Thank you for listening to me. Thank you very much.